So today we're going to talk about significant figures and how they are affected by mixed operations. Remember, in math, we have an order of operations: parentheses, exponents, multiplication, division, and then addition, subtraction. So when we're trying to decide how to round with significant figures when we have mixed operations, we first need to decide how to find the final answer by conducting a rounding at each step of the calculation. And then we need to round the value that we would have if we never rounded throughout the calculation. Let me give you an example. So in this example, we have 16.83 divided by 15 minus 0.46. The first step in order of operation would be the division. Division comes before subtraction. So 16.83 divided by 15, 1.122. And then the second operation would be subtracting it. So if I did not round, my answer would be 0.662. Now let's decide on the rule of where we should have rounded it. If we had rounded at the first step, division, which goes by the quantity of significant figures, the answer would be rounded to two significant figures, and I would have gotten 1.1 on the first stage. In the second operation, in the subtraction, the rule is going by place value, the least significant place value, which in this case is the tenths place. So I would need to round the answer to the tenths place because 1.1 is significant to the tenths place. So it would be rounded to 0.6. However, now I need to conduct that rule of rounding to the tenths place on the original answer. So in this case, I want to round to the tenths place on the value 0.662, which was obtained by not rounding. So that would be 0.662 would be rounded to 0.7. Notice that if we had rounded at every step, we would have ended up with 0.6. We end up with too much rounding error from rounding successively. Another example is often our percent error calculations. Absolute value of 50 minus 42.32 divided by 42.32 times 100%. So in terms of order of operation, the first step would be the absolute value. The absolute value is essentially acting as a parentheses, and parentheses come first. So we would subtract the value and get 7.68. Then we would follow that up with division, dividing by 42.32 and getting 0.181474. So that would, and then I do my multiplication by 100, ending up with 18.1474. That's not rounding at every step. We repeat the step, rounding at every step. So in my subtraction, on the first step, I'm going to go by the significant place value. The 50 is only significant to the ones place. So my answer would need to be rounded to the ones place. That would be rounded off to 8. When I then divided that by 42.32, division goes by quantity of sig figs, but 8 has a quantity of just one significant figure, so I would round the answer to one significant figure. Similarly, on the multiplication, when I multiplied 0.2 times 100 and got 2, 20%, that answer would have one significant figure because the 0.2 has just one significant figure. So my rounding rule is rounding to one significant figure. So I go back to the original answer, 18.1474%, and now I round it to having just one significant figure. In this case, that would round it to 20%. Notice in this case, I don't end up getting a different answer because of the rounding. It's so few significant figures, but I always have to be careful to proceed that way. So that was how you have to handle significant figures on mixed operations.